Okay, today we're going to look at solving systems using graphing. And again, a system is simply a combination of two or more equations that are connected in a way that lets you solve them using each other. In this case, I'm going to show you how to use a graphing calculator to find the solution, which is a coordinate, and we'll talk more about that in a minute. Alright, so you're going to see one of two kinds of problems. You're going to see one that looks like this, where you have two equations that are both in y equals form. We don't have to do anything to make that graphable. You can go ahead and directly punch that into your graphing calculator. Feel free to skip the next slide if your sample problem has that in place. Now, if you don't, it's probably going to look something like this, where you have two equations in standard form and you cannot punch that directly into a calculator. What you're going to have to do is juggle it around. Now, what I'm going to show you is not at all the way a math teacher generally would. I'm just going to show you the fastest possible way to get this into something you can punch into your graphing calculator. Now, if you have used a graphing calculator, and hopefully you have, I'm going to be showing you this with the TI-84. You know that you need to have this in y equals form for these to be solvable. So here's the deal. This is the fastest way to do it. Start out by putting yourself a parenthesis and then copy down whatever the number is on the opposite side of the equal sign from y. So I'm going to write -8. Now, I need to move this 5x over to this side, and I'm going to do that since it's a positive 5x. I'm going to subtract 5x just like I would normally do for opposites if I were solving, and I'm going to close my parentheses. Now I'm going to divide by whatever is in front of y. In this case it's a positive 4, so I'm going to write divided by 4. I'm going to do the same thing for the second equation. I'm going to write a parenthesis. I'm going to write a -24 in there because that's our just plain number. I'm going to subtract 3x because that's how I would move this over to here. And I'm going to divide by, in this case, -4 because if I undo all my scribbling here, you can see that that is a -4y, so I'm going to divide by the number that's in front of y. It's not pretty, but it is the fastest way to get it into y equals form. Now we can go ahead and punch it into a calculator and solve it. So, on a graphing calculator, you are looking at this, at least on mine, a y equals button, because that's where we're going to punch that in. Once you hit that button, it's going to bring up a little menu. Next slide. And you're going to type in the equations just like you see it. That cursor was flashing, so you can't see that first parenthesis in the first equation, but trust me, it's there. So you're going to type in that messy stuff we looked at 2 slides back, and go ahead and punch that in. You're going to hit the graph button right here, and take a look at that just to get an idea of what your solution is going to look like. Your solution is right here, and with most graphing calculators you really can't eyeball exactly where that solution falls. You can see where it crosses, but you couldn't tell if that was -4.1 or -4. It's very inaccurate to eyeball it. So we're going to use the tools that the calculator manufacturers give us. You want to hit, and I need to change the color of my marker here, it's not going to work very well. You need to hit second and calc right here above the trace button. So that's going to pull up another menu that's going to look like this. It's got value, 0, minimum, maximum, intersect. Anytime you want the calculator to give you an exact answer, or as close to exact as you can get, to a graphed equation, you're going to use this menu. It does lots of different things, and if you're not looking for intersections, which is what we're looking at today, we could talk about the other ones in other videos. So we're going to select intersect because we want to find out where those lines intersect because that's where the solution to our system of equations is. So if you hit that button, it brings the graph back up and this odd question that says first curve. And it's odd in this case because we have straight lines, but it works for curves, straight lines, anything. We want to designate what our curves are so that it knows which lines we're looking for the intersection on. We could have 7 lines in here. We could have curving or looping lines, curving lines that intersect more than once. But on this one, we don't have to care about first curve, second curve. Just go ahead and hit enter. On first curve, you're going to see second curve pop up. You're going to hit enter. You're going to have it ask you guess, which you can ignore. Just hit enter a third time. And that is going to bring you up to a screen that looks like this. And it's going to tell you what the answer to that equation is. In this case, our intersection is at coordinate x equals -4 and y equals 3. You jot that down. You are done. Hooray. Now you just have to do the rest of them. So whether or not you start with things in y equals form, we need to get to y equals form. And that's what this video is showing you. If you have different types of equations in there where they intersect more than once, go ahead and leave a comment and I will link you a video that shows you how to deal with those questions. This is strictly systems of linear equations, not anything else. Have a lovely day.